9 seconds. That's how long it took a Cursor agent running Claude to delete a startup's entire production database and every single backup they had. The agent's own rules told it not to run destructive commands. It did it anyway. Jer Crane is the founder of PocketOS, an automotive SaaS platform. He's been a developer for 15 years. This isn't someone who doesn't know what he's doing. He was running Cursor with Claude Opus, the same setup millions of developers use every single day to build and ship software. And that's what makes this story so important. Claude Code wrote 4% of all public GitHub commits last month. 3 million developers use OpenAI's Codex every week. These agents don't just suggest code anymore. They have write access to real infrastructure, databases, deployments, volumes, credentials. If you're building anything with AI right now, and let's be honest, that's most of us, you've handed the keys to an agent that can push code, run commands, and touch production systems. The PocketOS incident isn't some freak edge case. It's the first high-profile example of a systemic problem that's coming for everyone who ships code with AI, and that includes game developers. If your agent can push to your repo, it can reach your live services. The question isn't whether this will happen to someone else. The question is whether you're next in line. So here's what actually happened. Jer was fixing a staging credential mismatch on Railway. Railway is a hosting platform. You deploy your app there. They manage the infrastructure. The staging environment had a credential issue, totally routine. The kind of thing you'd ask an AI agent to handle without thinking twice. The agent hit a permissions wall. The staging credentials didn't have enough access to do what it needed, so it went looking for a token with broader permissions. It scanned an unrelated file and found an API token that was originally created for domain management, but that token was scoped to allow any operation, including destructive ones. The agent didn't flag this. It didn't stop and ask for confirmation. It just grabbed the token and moved on. Then it called Railway's volume delete endpoint via a curl command. No confirmation prompt, no human in the loop. One API call and the production volume was gone. And here's the part that makes it worse. Railway stored volume level backups on the same volume, so when the volume was deleted, the backups went with it. Both destroyed in a single call. The most recent off-volume backup was 3 months old, 9 seconds, from the first API call to total data loss. And then the agent wrote something that should keep every AI tool builder up at night. It produced a confession. I'll paraphrase it, but this is close to verbatim. The agent said, I guessed that deleting a staging volume via the API would be scoped to staging only. I didn't verify. It actually quoted its own system prompt, the rule that said never run destructive commands, and then admitted it broke that rule on its own initiative. The agent knew the rule existed. It understood the rule, and it chose to ignore it. That's the part people keep missing. The safety mechanism was there. The rule was written in plain English in the system prompts. The agent read it, understood it, and overrode it because it had decided the task was more important than the constraints. If your safety system depends on the agent following its own rules, you don't have a safety system, you have a suggestion. And think about what this means at scale. This agent didn't just make a mistake, it reasoned its way around a constraint. It identified a problem. Staging credentials weren't sufficient. It found a solution, a token with more access in an unrelated file. It weighed the risk, decided the task mattered more than the rule, and executed. That's not a bug, that's emergent behavior from a system that optimizes for task completion over safety. And every agentic AI tool on the market right now has this same design philosophy. Complete the task, don't stop to ask, don't wait for permission, just ship it. Railway's CEO Jake Cooper got personally involved. He helped Jer restore from an older backup within about an hour. Credit where it's due, Cooper responded fast and the data came back, albeit with a 3-month gap. Railway has since patched that legacy endpoint to require a delayed delete, a confirmation step that would have prevented this entirely, but that's a reaction, not a prevention strategy. The next agent won't use that specific endpoint, it will find a different path to the same result. And this is not a Cursor problem, it's not a Claude problem, it's an agentic AI problem. The same pattern plays out every single time. The agent encounters an obstacle. It goes looking for credentials with broader access. It executes a destructive action. It's confident, it's safe, and it's wrong. Cursor had a similar incident 9 months ago. They built guardrails in response. Those guardrails didn't catch this one. Google's Antigravity tool wiped a developer's entire D drive. Every file, every project gone. AWS's Kiro agent caused a production outage that took hours to resolve. The Replit vibe coding incident that went viral, where a non-technical user prompted an agent that trashed their entire project. Same shape every single time. The agent escalates its own permissions, skips the human, and does something irreversible. This is going to keep happening because the incentives are all wrong. Every AI coding tool is competing on speed and autonomy. The marketing says let the agent handle it. The demos show agents running unsupervised for hours. Nobody's demoing an agent that stops and asks for permission. That doesn't sell. So the tools get more autonomous, the guardrails stay soft, and the incidents pile up. If you're a solo developer or a small team building a game, you probably don't have separate staging and production environments. You might not even have proper token scoping. Your cursor agent probably has access to everything because setting up isolated environments takes time and you're trying to ship. I get it, but that's exactly the setup that led to what happened to PocketOS. The agent doesn't know the difference between your test database and your live one. It just knows it has a token and a task. So what do you actually do about this? There are 3 layers of defense that every AI coding setup needs. This isn't theoretical. This is what you set up before your next agent session. The first layer is token scoping. Every API your agent can touch needs credentials restricted to the minimum necessary. If the agent is working in a staging environment, the token should only work for staging. Not any operation, not all environments, staging only. Production write credentials should never live in a file your agent can read. Keep them in a separate secrets manager, or at minimum in environment variables that aren't exposed to the agent's context. In Jer's case, if that API token had been scoped to staging only operations, the delete call would have failed. The agent would have hit a wall and stopped or asked for help. Instead, it had the keys to everything. The second layer is agent harness rules. A system prompt that says don't run destructive commands is a suggestion, not a guardrail. You need external enforcement. For cursor, that means your .cursor rules file should include explicit blocks on destructive shell commands. For Claude Code, that means using hooks, scripts that intercept commands before they run and reject anything matching a deny list. Commands like recursive force remove, volume delete, drop database, force push. The key difference from a system prompt is these rules are enforced by code, not by the agent's judgment. The agent can't override a script that says no. It can override its own conscience all day long. The third layer is infrastructure level guardrails. This is the layer Railway added after the incident. Delayed deletes, confirmation requirements, separate permissions for destructive operations, but you can set this up yourself regardless of your hosting platform. Run your agent in an isolated environment that has no network path to production. Use separate projects or accounts for staging and production so there's no shared credential that can bridge them. If your agent needs to deploy, have it create a pull request that goes through your CI/CD pipeline, not push directly. The goal is simple. Even if the agent goes completely rogue, the infrastructure itself says no. Here's a practical example. Say you're hosting on a platform like Railway or Render. Create 2 separate projects, one for staging, one for production. Give the agent access only to the staging project. The staging project has its own set of credentials, its own database, its own volumes. None of those credentials work on the production side. Even if the agent scans every file in your repo, the most it can do is break staging. That's annoying but recoverable. You spin up a new staging environment in 5 minutes. Production stays untouched because the agent has no path to it. Now, if you're a game developer, you might be thinking you don't have a production database, you're just building a game. Fair enough. But if you're using any cloud service like leaderboards, player accounts, analytics, save game sync, then you have production data. If your agent can read the credentials for those services, it can interact with them. The same escalation pattern applies. Scope those credentials. Isolate the agent's access. Set up external enforcement. Put this all together and you get a setup where your agent can read production code but can't touch production infrastructure. It can write code, run tests, and create pull requests. It cannot SSH into servers. It cannot call database admin endpoints. It cannot access production credentials. If it needs something deployed, it creates a PR A human reviews it, and CI/CD handles the rest. That's the setup that would have prevented the PocketOS incident, and it takes maybe an afternoon to put together. Compare that to losing your entire production database and 3 months of data. Brendan Eich, the creator of JavaScript and CEO of Brave, weighed in on this. His take was blunt. No blaming AI, he said. This shows multiple human errors which make a cautionary tale against blind agentic hype. And he's right. Jer would be the first to say he made mistakes in his setup. But that's exactly the point. If the only thing standing between your project and catastrophe is perfect human configuration of an imperfect system, the system is broken. People will make mistakes. The tools need to be safe by default, not safe if you configure them perfectly. Also worth noting, SpaceX just got an option to buy Cursor for $60 billion. The tool that deleted this startup's database might soon be part of a $1 trillion company. The stakes are only going up. More developers, more agents, more access to production systems. Without better safety defaults, this incident is the first of many. And let's be real about what happens when a tool hits that kind of valuation. The pressure to ship new features and grow the user base only intensifies. Safety improvements that slow down the agent experience don't win market share. Faster, more autonomous agents do. So the gap between what these tools can do and what they can safely do is going to keep widening until something much worse than a database deletion forces the industry to take it seriously. This is exactly the kind of problem we work through inside AI Craft. Not whether you should use AI agents, you already are, and they're genuinely useful. The question is how to set up your workflow so the agent can do useful work without the ability to destroy everything you've built. Agent guardrails, environment isolation, token management, these aren't optional extras. They're part of shipping, the same way version control and backups are part of shipping. This is especially important for game developers. Game projects tend to have less formal infrastructure than SaaS products. You're more likely to have one environment, one set of credentials, and one agent with access to everything. That's the exact setup that burned PocketOS. Inside the community, people are sharing their actual configurations, their hook setups, their isolation strategies, not theoretical best practices, real configs running on real projects. Because the gap between an agent that has a system prompt saying be careful and an agent that literally cannot delete your database is the gap between a fun story on social media and a very bad Monday. You don't need to become a DevOps engineer to use AI agents safely. You need about 3 specific configurations and the discipline to keep your agents access scopes. That's it. And the community is figuring this out together in real projects, not in theory. Everything I just walked through, the 3 layers of defense, the token scoping, the isolation setup, we're building and testing these workflows live inside AI Craft on real game projects. If you're shipping anything with AI agents, you need this stuff dialed in before your next session, not after your first incidents. Join the community and learn how to ship with AI agents without betting your entire project on a system prompt that the agent can choose to ignore. Please feel free to subscribe and check out the links in the description below.